Okay, next from Unit 2, we'll see about closure properties of regular languages. So from this topic, after learning of your closure property of regular languages, the outcome you will get is you'll be able to perform reversal, homomorphism and inverse homomorphism on regular languages. Then you'll be able to perform closure properties of regular expression. So these are all your top properties we are going to cover. So totally 7 properties we are going to cover this. First one, properties of regular set. So first property, union of two regular set is regular. So we have to prove that union language of a regular set is regular. So how we are going to do that? So first, let us take two regular expression. So I am representing it as RE1 over here, RE1 A of AA star, one regular expression, and another regular expression too is AA of star. So for this RE1 and RE2, I have to prove union of two regular expression is regular. So how I am going to do is, so for first one, A of AA star, what do you mean by this? That is, starting it should have one particular, it should start with A, and after that it can have any number of your combinations. So A, that is, sorry, after that you should have your odd length of your combinations. Okay, so in front itself you're starting with A, so obviously it will be having only your odd length values. So A is an odd value, then triple A, so that is A cube, then after that A power 5. So for this particular regular expression, the language is of my odd length. When I take my regular expression to, it is AA star. So this is of my even length. So that is A power 4, A power 6, A power 8, like that. So it is of my even length. Now when I perform my both the languages, my union operation, so as I told you, it is starting with, it has your epsilon closure. So you have to start with our epsilon symbol at the starting, then followed by this single A, then AA, then A power 4, then A power 6. So my output over here, how it is going to be? It is going to be of my all possible combinations over here. That is epsilon, then single A power 1, A power 2, A power 3, A power 4, A power 5, A power 6. It will be keep on going. So it is of my all possible length. Okay, so this is how you will be performing your union of two regular set. So first one particular regular expression they have given, another regular expression they have given. So from that particular regular expression, we are representing how the language will be represented. One is of my odd length values and another is my even length values. When I combine both my language L1 union of my L2, I will be getting all possible lengths. So this is your union of two regular set. Next, property 2. It is intersection of two regular set. So if I take over here, one regular expression is of AA star, another is of my AA star. So if I take A of A star means all possible length excluding my null. Okay, so all possible length excluding my null. Then if I take my second language, it is of my even length. So when I perform my intersection operation, what this epsilon will be eliminated. I'll be having my this AA, next 4 A's and my 6 A's. So that is when I perform my intersection operation, the answer I'll be getting is of my even length only excluding my null over here. Okay, so for my first expression I am excluding my null, and in my second expression I am including my null. So when I perform the intersection for both the language, the answer output is going to be of my even length excluding my null operation over here. At last, so L1 intersection of L2, this is my final expression, AA of AA star. So hence intersection expression is proved over here. Next, property 3. The complement of a regular set is regular. So complement. So regular expression AA star. So this is only one regular expression over here. How I am going to perform my complement operations. So when I am having AA of star, it is even length, starting with my null symbol over here. When I perform my complement, it is going to be the opposite of it. So odd length over here, even means it will be performing odd operation. So single A, 3 A's, 5 A's, then 7 A's, like that it will be keep on going. So at last the complement of my regular expression is A of AA star. Property 4. The difference of two regular set is regular. Two regular expressions A of A star and AA star. So strings of all possible lengths. If I take the language for this first regular expression, accepted strings are A, AA, triple A and 4 A's. So strings of all possible lengths excluding null. If I take my L2 second language, epsilon with AA, 4 A's and 6 A's, strings of even length. When I perform my difference operation, I'll be getting my odd length values 1, 3, 6, 7, like that. So when I perform my difference operation, I'll be getting my answer as odd length values. So L1 minus L2, if I perform, the final expression is A of AA star. Next, property 5, the reversal of a regular set. So for reversal, how I'm going to perform is the power I'll be representing it as capital R. So this R represents nothing but my reversal operation. Okay. So for example, this is my language 01101110. For this, I have to perform my reversal operation L power R. So 01 means I'm going to change it as 10 over here. Over here 10 means I'm going to replace it as 01. 11 means as it is 11, this cannot be changed. Vice versa, if you do the same thing only. Over here 10 means 01 I am performing. Okay, so this is my regular reversal. So hence I have proved for reversal operation. Next, property 6 is closure of a regular set. So over here if I take L, odd length values I'm taking A, 3, single A, 3, then 5. So this is my odd length. If I perform my closure operation over here, so L star means this is single A, 2, 3, 4, 5. So that is strings of all length I will be performing over here because it is closure of my regular set. Next, property 7. If I perform concatenation, how it is going to be done? So this is my one particular expression 0 plus 1 star 0 1. So this is the meaning is starting it can have any possible of combinations of zeros and ones, but ending it should be of my zeros. Over here starting it should have only 0 1, ending it can have any number of 0 plus 1. So this is my accepted language for L1 and L2. So if I perform concatenation, so this is the answer I'll be getting. So this 0 and the starting 001 I have taken and written. This 00010. So first two zeros, then 010. Then over here 101011. So vice versa, we have to take and write everything together. So at last, my regular expression for concatenation is 0 plus 1 star 0 0 1 bracket 0 plus 1 the whole star. Hence, we have proved the concatenation. So these are the 7 properties of our regular set. Okay. So from this topic, at last, what we have learned is how we are going to define the complement of a regular set, then how we are going to define the closure of a regular set, then concatenation of your regular set. Okay. Thank you all.